All right, on top of your weather notes, go ahead and write down the answer to this question. Stop the recording so you can write down your answer. Basically, what do you think humidity is and how does humidity make you feel? We live in the South, so we know it's all about the humidity. So when you watch a weather forecast, they don't generally talk about humidity. What they do talk about is relative humidity. And relative humidity takes a couple of things into hand. So if you wrote about humidity and you said it's like how much moisture is in the air, you've got it. But relative humidity takes it one step further. It basically looks at temperature too, because the temperature of the air is going to be indicative of how much water the air can hold. And it's why the South is so humid in the summer, because we're so freaking warm, and warmer air can hold more moisture. So we tend to have a lot of humidity here. So relative humidity is the amount of water vapor in a volume of air compared to how much water vapor that volume of air can hold. So we do a comparison. Okay, so it has this much water in it at this temperature. If we look at it and say how much it could hold, what is a possibility of what it can hold, how much excess can it hold? Okay, what's the comparison between the two? What it's holding right now to the max that it can hold. So as I said, warm air is capable of holding more moisture than cool air. It's expressed as a percentage, so you've seen this in the weather forecast when they say it's 70% humidity. Well, it's 70% relative humidity. So when you say it's 70% relative humidity, it's saying at, let's say the temperature is 90 degrees. At 90 degrees, this air mass is holding 70% of the moisture it could hold. If it's 50 degrees relative humidity, at 77 degrees outside. So if it's 50% relative humidity, then it's saying at 77 degrees outside, it can hold 50%. It's holding 50% of the moisture it can hold. So cloud formation, we're going to talk about some of the basic clouds out there. Basically, clouds are going to form when warm, moist air rises. And remember, when it's warm, the atoms like to move out. They are energetic, so they spread out. They expand. And then when they expand, they start to drop, and you get a convection current going on, and little droplets of moisture are released. And those little drops of moisture don't come down necessarily as rain yet. What those little drops of moisture do is they grab onto little pieces of dust in the air. And when they do, and you have lots of these little pieces of dust in the air, these little particulates in the air, given a term for them, we call them condensation nuclei. They grab onto these little guys, they hang on, and at that point you have a cloud. So one of the things you may have noticed if you've gone to the mountains is that there tends to be a lot of clouds up at the top of mountains, and that is due to orographic lifting. So basically you have warm air rises and it goes up the mountain side. It's going to cool off pretty quickly as it goes up because things is cooler up there. And as it does, little moisture particles are going to come screaming out of the air and grab onto the condensation nuclei, and you're going to have lots of clouds. You're also going to have cloud formation when you have air at different temperatures, large masses. So a lot of times when we have our weather that comes through, it's due to large masses of air that have different temperatures and different amounts of moisture. And when you do, you have cloud formations. And when you have cloud formations, oftentimes you're going to end up with some precipitation. So if you listen to the weather reports, they often will talk about having unstable air or air stability. And how rapidly any mass of air cools determines its stability. It's the ability of an air mass to resist rising. If it can't resist rising, if it goes up really fast, you have an unstable atmosphere. An unstable atmosphere usually lead to rain and storms. So when we look at clouds, and I'm just going to give you the cloud basics here. There are multiple subtypes of clouds, but we're going to talk about the real basic ones. We group them by altitude and shape. Low clouds form below 2,000 meters. Your middle clouds are between 2,000 and 6,000 meters. And your high clouds, which aren't really little droplets of moisture and condensation nuclei, they're actually ice crystals at that point. They're about 6,000 meters. So when we look at naming clouds, we use prefixes to talk about height of a cloud. And we also will use prefixes to talk about the shape of a cloud. So cirro tends to be your high clouds, alto tends to be your medium clouds, and strato tends to be your lower clouds. When you look at shape of a cloud, nimbus tends to be your low gray rain cloud types. Stratus, these are sheets of clouds. These are the ones when you can't see the sky at all or the sun at all. Cumulus, means piles or heaps. So these are your fluffy white cotton clouds. These are also the ones that can grow fantastically and turn into some really nasty storm clouds. And cirrus are those little wispy clouds that you see up in the sky. All right, so we got some information about how low clouds form. The low clouds are often going to bring precipitation. And you guys have all seen these. Your middle clouds here are usually layered, and your high clouds, like I said, they tend to be made of ice crystals. They have that wispy look to them. These guys don't make precipitation, so if you see these wispy clouds, you're good for the day. So remember when I talked about cumulus clouds, how they're cute and they're fluffy white cotton balls? Well, sometimes if it gets really unstable there, that cloud will grow, and it grows. And there's a lot of heat being released, which means there's lots of energy being released. And energy up there is usually not a good thing. It can grow up to 18,000 meters. And then we call it a cumulonimbus cloud. With these guys, you get heavy rain, strong winds, thunder, lightning, hail, and even tornadoes possibly. So cute little cumulus clouds on top, evil cumulonimbus clouds on the bottom. All right, so we're not going to do the relative humidity lab. Unfortunately, guys, this is so sad since we're stuck in this situation. We don't get the fun of this. It was a cool lab. I'm so sorry you guys don't get to do it. It sucks.